Ericsson is one of the largest countries for Ericsson in Poland is one of the largest countries for Ericsson. We have over 3,000 employees here, and we have 2,000 research and development engineers developing radio software for all technologies, including 5G, in Krakow and Łódź. So we are really trying to make sure Poland is the leader in this knowledge-based society. Let's kick off with a video, please.
Over the years, we have connected billions of people. We have laid the foundation for innovation and growth, and we have brought it everywhere. But this time, it's different. Now, our IoT, 5G, and automation technology stands ready to unlock a wave of new value. We're talking operating rooms connected across oceans, trucks communicating to increase efficiency, and factory floors going fully digital. We'll see waste reduced, accidents dramatically decrease, and remarkable new business models come to life. But we're getting ahead of ourselves. To make this a reality, we're on a quest. To make technology easy to use, adopt, and scale. To build an ecosystem together with our customers where change is easy, where standards are global, and where the full value of connectivity can be realized faster than ever. Getting to easy won't be easy, but we're determined to lead the way, to move fast, to knock down barriers, and to cut through complexity. Join us.
So, those of you who were in Barcelona last week at the Mobile World Congress would have seen 5G in every show area. You would have thought 5G is here and now. Well, maybe not right now, but it's getting very close. The standards for 5G, non-standalone 5G, were defined in December 2017. And typically the product life cycle is 9 to 12 months before you will see products hitting the market. So in some of the countries that were mentioned earlier today by Mr. Lee, like the US, Japan, China, Korea, you will start to see early 5G deployments at the end of this year, and many more leading into 2019. Of course, these will be gated by device availability. Now, as for Europe, then the single digital market, the European Electronic Communications Code, and the aim for the digital society mean that we'll be following very, very quickly, I believe. So by 2025, the gigabit society with 1 gigabit in every school, every public institution, 5G on every transport route, on rail, road, and urban area, and with the first 5G city in 2020, the European Union has set the standard that it expects from each member state. So these things will happen very quickly. But let's talk 5G. I'm going to talk a little bit about the infrastructure and the technology that's going to enable 5G. And a lot of the talk is about spectrum, about radio, but 5G is more than that. It's an end-to-end architecture, and I'll be touching on some of these points during my presentation. So 5G is one network supporting many multiple use cases. Here I just highlight some: enhanced mobile broadband, massive IoT, water meters, pollution sensors, critical IoT, autonomous vehicles, remote operations, and fixed wireless access to complement fiber to the home. But which will be first? What will be the first use case, and where will the money come from here? Well, to look at the first use case, we need to think about what will 5G be used for and what comes with 5G. And of course, you have much higher throughput, much higher capacity, lower latency, longer battery life. The 5G is also about making sure the network is more efficient to run. We've seen in the last 5 years, data rates increase globally by 65%. In the next 5 years, we predict they will increase by another 40%. 8 times more by the time we get to 2023. And therefore, network operations needs to be much more cost effective. You see also on this slide 5G traffic in 2023. We forecast 1 billion 5G devices by 2023. But with this type of growth, service providers need to be able to provide the cost per bit at a much lower level. And whilst 4G expansions, the introduction of massive MIMO, is going to increase capacity by 3 to 5 times, it will need the new 5G network with new frequencies, the new air interface, and other techniques like MIMO in order to get this cost per bit down. So we're forecasting that a 5G site will be providing the cost per bit at 1/10 of that of a 4G site. And that's why we think that enhanced mobile broadband will be one of the first use cases, not just to provide the extra capacity that's needed and the extra throughput that's needed, but also to make sure that cost per bit is as low as possible to make the network operationally effective. But there will be other use cases as well. And here I try to show the volume and the value associated with these. Evolved mobile broadband will be the leader in terms of the size. But IoT will also be very large too. And I put here between 200 and 600, and that depends on the positioning of service providers in providing IoT. And fixed wireless access will follow also. But before we talk about technology enablers for 5G, it's important to talk about 4G, and there's still plenty of life left in 4G. We see technologies like carrier aggregation, massive MIMO, lean carrier, reducing the amount of radiation in the network, high order QAM. All of these techniques will drive 4G to 1 gigabit and even 2 gigabits per second in the future. And even the first 5G deployments will be dependent on the 4G network. That is what the non-standalone 5G standards defined in December 2017. So 5G will be an overlay on the 4G network. So 4G is really important as we move forward into this 5G transition. So let's talk about the technology enablers that are going to be coming in order to make 5G a reality in Poland and other countries. And it is going to be end-to-end. For sure, it will be the radio technology, the spectrum, but it will also be the core network. It'll be the business support systems. It'll be the IoT enabling platforms. And what we need to do as an industry ecosystem is to make this transition as low cost as possible. And therefore, we have a belief that as much equipment that's used in the 4G network today should be used in the 5G network. If I take radios, the radios that are on top of every mast that you see that's providing your connectivity today, we will be providing software at the end of this year that will mean every single radio that's been sold since 2015 will be upgradable to 5G on the existing frequencies. And we showed in Barcelona, we will have dynamic 4G and 5G spectrum sharing so that there's no need for any new investment in radios with the same frequencies. Of course, new frequencies like the 700, the 3.4 to 3.8 and higher that were mentioned by Martin will certainly need new radios. But the existing radios can all work with a 5G software and 5G air interface. The basebands that are deployed today that are aggregating all of this radio traffic, they are already 5G enabled, 5G ready for the capacity that's coming. But moving away from radios for a moment and spectrum, The core network is vitally important for 5G. And yes, there will be virtualization, there will be programmable networks. But here I raise a point called network slicing, how different applications can get access to the core network and to have their guaranteed service level to make sure that their application is going to work guaranteed and seamlessly. This is a very important part of the core network, and you're going to see these network slices appearing very, very soon. The other part is the distributed cloud infrastructure. Fiber optics is extremely important for 5G networks, as the core will be distributed, and we will have centralized, distributed, and edge core networks, meaning many, many core networks across Poland, and this is to serve the low latency edge devices that we'll need to have for autonomous cars and remote surgery and other such instances where critical milliseconds make a difference to machines talking to machines. But it's also machine intelligence. So I raise here machine learning and artificial intelligence. Machine learning we see driven by massive amounts of data in the network, big data, data science being applied to this, and artificial intelligence, the massive application of logic. And these two are coming together in radio networks and core networks to make them much more efficient. But then it's the business support systems as well. Today's billing systems are probably run once a month, typically. They target consumers, postpaid consumers. In the future, there's going to be many industries that are going to be using this technology of 5G, and therefore the billing systems need to evolve as well, so they become real-time and location-based. And you just need to look at the way that when you go with Uber and you get your real-time location-based bill, how the billing solutions for service providers in the future need to evolve. And one other critical component to the 5G network is an IoT platform. Ericsson has the IoT accelerator. This is the platform that will pull together the devices, the applications, and provide them and make them available to industries to use. And this will bring together connectivity management, security management, billing management, and overall management of the platform. And this is a vital component for service providers to make sure that they take a major stake in what is going to become the industrial internet, and that Europe is a leader and a winner in the industrial internet. By the industrial internet, I mean the fact that 5G is going to be used by humans, of course, but it's going to be used much more by machines and industry. And this phrase, the industrial internet, I believe you can apply to the 5G network in the future. And whether there are examples on here like connected cars, smart energy, intelligent transport systems, public safety and transport like trains, then the industrial internet is going to be crucial. And we have done a study with Arthur D. Little, and we have looked at all countries in the world, and specifically Poland, to see where will the revenues come from. And we see that digitalized revenues associated with 5G will come mainly from manufacturing, energy utilities, and public safety in Poland. And looking at the type of increase that we see that can occur for service provider revenues, we can see an uptake of around 40%, looking out 10 years in time. So the industrial internet, we believe, can be a major new source of revenue for service providers and the industry. I will finish on one last slide. We were fortunate that President Duda came to Sweden at the end of 2016 and visited Ericsson. And he advised focus on bringing partnerships together for industry, R&D, academia, service providers, startups. And that's exactly what we have been doing. And with our 2,000 R&D software engineers developing 4G and 5G technology in Krakow and Łódź, then I really believe that we will contribute significantly to Poland's economy growing through innovation and entrepreneurship, this knowledge-based society. And I see that for 5G, Poland not just has an opportunity to be one of the first users of 5G services, but with the R&D skills in Poland, it has a unique opportunity to be contributing to the development of the 5G network and therefore be a leader in innovation in Europe. With that, I say thank you very much.